Hey, what's up? Leetcode 1840, maximum building height. You want to build n new buildings in a city. The new buildings will be built in line or labeled from 1 to n. Okay, for some reason it's not 0 to n, whatever. However, there are city restrictions on the heights of the new buildings. The height of each building must be a non-negative integer. The height of the first building must be 0. The height differences between any two adjacent buildings cannot exceed 1. Additionally, there are city restrictions on the maximum height of specific buildings. These restrictions are given as a 2D integer array restrictions, where restrictions of I equals I d I max height indicates that building ID must have a height less than or equal to max heights, guaranteed that each building will appear at most once in restrictions, and building 1 will not be in restrictions. Return the maximum height of the tallest building. Okay, so cap equals n times n. What is the cap? All right. So n is the, oh god. Oh shit. Well, that ain't gonna work. Okay, I did think that I could make an array of every position, but I suppose not. Okay, we're not going to be able to iterate all of the values. So we need to know the distance between the height restrictions, and we need to add a height restriction. So we're going to say restrictions dot insert 0, comma ID, wait, and height. Yeah, and then we will say restrictions equals I minus 1 comma j for I comma j in restrictions, and we will make these tuples, and then I don't know if they're sorted or not, so we're going to sort them. And you just want to figure out what the midpoint is, and then the furthest between the 2 points is how tall you can get it, right? I mean, is there some other limitation? Well, it seems like every single restriction is going to propagate forward. Oh, so you're saying if you had an older restriction, that might still be relevant on a going forward basis. Okay, yeah, that makes sense. But in that case, we could just update the restriction. A more lenient restriction absolutely is irrelevant, and the restrictions go, let me think, left to right and right to left, right? So yeah, that makes sense. So it almost seems like we need, yeah, because each one of them are going to increment. Okay. So we have 10 to the 5th times 10 to the 5th, which is too big. Hence the hard rating. So we need to know what the most restrictive thing is at any given point in time. We need a way to organize them, to be honest. Okay. Anything that is less restrictive can be removed. Anything that is more restrictive will offset the previous value. Right? So to be completely honest, that sounds like at most one counter moving forward. So we're going to say current I, current J, well, current M equals restrictions of 0, right? And then we're going to say for I in range 1 to length restrictions. Yeah, it seems like the midpoint between each of them. We won't worry about that one right now. So yeah, 1, 2 length restrictions. We'll have remove like this. And we would never get rid of the restriction at 0. So yeah, so adjusted CM equals CM plus I minus CI, right? If they're the same, then that's 0 and we get CM. If this is 1 higher, then this is increased by 1, yes. And then it's very, very simple. IM, I, and then yes. So what would we do if it were equal? Yeah, that's very interesting. Is it possible that we don't want to remove something? Yeah, we want the most stringent requirements. I feel like actually removing something could be a problem, though. So if adjusted CM is less than IM, then we're going to simply replace it in place. So restrictions of I is going to be equal to I comma adjusted I don't remember what it stood for. I think I said it like 2 seconds ago. Yeah. If it's equal, then it doesn't matter. What if this is greater? If it's greater, then it's less restrictive, and that's not a problem. Trivial. Absolutely trivial. Okay, we will probably need to add an ending boundary. But, well, no, we won't. No, we won't. We'll figure out what the last boundary was, and then we'll figure out what the ACM is of that to the furthest position right. Yeah. So nothing gets removed. CI of CM of restrictions -1. Trivial. Yeah, kind of fun, actually. Reversed length restrictions -1. ACM equals CM. Yeah, this is similar. Wait a minute. Yeah, that's right. Okay, so it's actually going to be CI minus I because we're going the other direction, basically. So this is going to be the bigger one. Yeah, and then, wait a minute. Do we ever replace CI? We don't replace CI. That is a problem. So if ACM, here, just do it like this. So CI-CM equals restrictions of I This is incorrect. This should be II. And this should be II. All right. Okay. Original restrictions. You see, now I'm all paranoid. Equals restrictions dot deep copy, I guess. Is that a thing? I feel like that's not a thing. Return 0. I mean, there's definitely something called deep copy, but I don't think this is how you do it. So original restrictions equals I minus 1 comma j for I comma j in restrictions. Yeah. And then we need to do an assertion. Assert all original I equals new I for oh boy. Original I, comma, don't care. New I, comma, don't care too. In zip. Restrictions, comma, original restrictions. Because if I'm messing this up, then it's going to mess up the whole problem, and then I don't know what we're doing. In for what? Well, for this. Ah, shit. That means I really did screw it up. I mean, it's better that I know that I screwed it up, but... Okay, let's see. Make sure that it was all right here. It was not all right here. Original I, new I. See, it should be right there. So Okay, something is clearly wrong here, so I'm going to say for I in range length restrictions, right? And then it's going to be restrictions I0 equals original restrictions I0. I don't know why the zip wasn't working, so. What the hell? Oh. They really are being delivered out of order. Well, I'm going to check that. Okay, cool. That means that I am not changing them, which is good. We no longer need the assertion. And if we've gone both ways, then we're ready. Okay, so the first one is going to be final position equals n minus 1. Right? Yeah, and there's at least one restriction, right? Well, we know that we entered the beginning one, so there has to be one no matter what. Okay, so CICM. So we know that we have advanced further from that. So the best from this standpoint is going to be obviously what am I trying to say? CM plus final position minus CI, and which is going to be less than or equal to it. Yeah. And then points to check is going to be a set. I'm trying to think if there's an exception, and I'm just not thinking of anything. So I'm going to say yeah. Excuse me. So we're going to have last CI equals, I don't know, I guess 0 or something. And we'll have for CI, comma, CM in points to check. And not points to check, no, in restrictions. We just want to check every single point, and we don't know whether the midpoint is the best or previous or whatever. So it's going to be points to check dot add, and it's going to be CI minus 1, CI plus 1, and then it's going to be halfway in the middle between that and the last one. So midpoint equals CI plus last CI whole thing divided by 2, and then points to check equals midpoint and midpoint minus 1 and midpoint plus 1, right? And that's that. I don't think that there's any other points that we would want to check. I hope that there's no other points we want to check, so let's figure this out. Okay, now each point to check is going to be sandwiched between 2 additional points, right? Well, okay. points to check equals I for I in points to check in sorted points to check if I is greater than or equal to 0 and I is less than n. Because we can't have it going off the edges. Right? Okay, so yeah, now if it's right on the boundary, then probably doesn't really matter so much. Yeah, it does. Yeah, it does, because we need to look behind and ahead. Right? So I think restrictions is going to have added is there going to be one behind? That append n comma 10 to the 9th plus 1 or something. Effectively no limit, right? And then we're going to have restrictions dot insert restrictions dot insert insert at 0, and then it's just going to be, well, at 0 we insert -1 comma 0. Okay, so we should always have one greater and one lesser. So I comma j equals 0 comma 0. And then we simply advance through the points. So we have for I in, well, that's not going to work, is it? For k in points to check. And we know this is sorted, and we know that it is in range. So I should be less, and j should be more. Right. And I think that we should add one more just to prevent overflow. So while now it's not less than or equal to, it's less than, right? And we should probably check if it specifically exists. If it's straddling two of them, then we know that there's one sandwiched in the middle. Okay. Absolute requirements. It's just easier this way. I for I comma j in points to check, and it will be I comma j just like that. So check if exact. So while restrictions of I plus 1 of 0 is still less than k, we're going to say I plus equals 1. And then while restrictions of j is lesser than or equal to k, then we're going to say j plus equals 1. And then we'll see, assert I is less than j, should always be less than j. And restrictions of I of 0 is strictly less than k, and restrictions of j of 0 is strictly greater than k. Now, if I plus 1 equals j, then assert k not in absolute requirements, else assert I plus 2 equals j and k in absolute requirements. Is that right? Cannot unpack. Way up here, points to check. No, not points to check, restrictions. That is the second time that I've made that exact error. All right, cool. Our assertions passed. That means that we should be able to put this. Didn't we populate it best? Where's best? Where's best? I thought we had a best. Yeah. Here we go. So best, return best. Now we are checking these points. So maximum, okay, if k in absolute requirements, then maximum value equals what? Well, equals absolute requirements of k. All right. Then we're going to have I and j. So let's look at this. I1, I don't know what these abbreviations stand for. Equals restrictions of I. Okay. Minimum value equals min of minimum value, comma, IH plus k, which should be bigger, minus I1. Right? Yeah. And J1, JH, restrictions J, MV equals MV of, and then it's just like above. And then best equals max of best, comma, MV. And I think that should work. Or not. Output 0. Now, why would it be 0? How incredibly annoying. Okay, let's see. Best equals max of best. So print k. k comma I1 IH J1 JH. And here we go. So k increments I1. See, there's ones in here. They're ones. MV equals min. J1 is just a position, but JH. So what is N? Where is N? N is 10. Oh. Yeah, I don't know why. We must have screwed up when we added in this final termination here. Yeah, that should be 10. Where the hell is the -1 coming from? Well, I think that is our bug now, isn't it? Okay, so the initial restrictions are 10.3, which would become 9.3, right? One of these has to be filling it in wrong, and I have a feeling that it's probably this one. Help if I scroll to the right place. So II ACM. Yeah, CI CM. So if ACM is less than IM, so the adjusted, calculated, measured, I don't know what ACM stands for, equals CI minus I, but we're going backwards, right? Oh my God, are they both backwards? CI is older, so I is bigger. CI is older, which stays bigger as this drops smaller. Yeah, so if it's equal... See, ACM should never be -1. If ACM is -1, then there's a problem. Print ACM. And print ACM. I need to know where the -1 is coming from. So right here. Interesting. Okay. If ACM equals, well, if it's less than 0, then I need to know where we are looking. So let's say CICM IM restrictions. Then of course it would be smaller. So okay. So it only happens once. So CICM the index 0, 1, 2, 3, 4. So we did already add it, yes. So here is our array. Position 9, max of 3, which is this one right here. Did I print ACM? I don't think I printed it. So ACM equals CI plus I, so 10, right? I keep losing my damn place. Minus CI. Oh, CM minus CI. Well, that would be -1, wouldn't it? Okay. Okay, so obviously I'm doing something wrong. This is the index, and oh my God. I did it again. I can't believe I did it again. Okay, so let's look again. So I'm outputting 3, and I should be outputting more. So I guess we're less wrong than we were before? Yeah, that's the right way to think about it. Okay. So it should be higher than 3. This is the third example. Let's see here. So boom, boom, boom. 7, 7, 8, 9, 10. So 7, yes. But we must be marking it down somewhere. Let's look at the final restrictions before we run this. Print restrictions. 6.4, that is correct. 9.3, that is correct. So we should check 7. We should check 7. Is my checking algorithm not covering all the bases? Yeah, there could be a maximum point between 2 that I wasn't really thinking about. But not in this case. So these are actually correct, right? 6 and 9, and then the positions to check. Did we filter it more strictly than we should have? I is less than n. Oh no, did I overwrite n? n forward. Okay, so we're adding restrictions here, but do we add the points? Points for every point based on restrictions, and the ending point. Okay, what are we printing down here? Points to check. Print points to check. Okay, yeah, so 7, 8, 9. And yeah, calculating the maximum between the two is it might not be the center point. That might have been a mistake. I need to figure that one out. But that's not what's happening here. I need to fix this first. So 7. What does it do when it's 7? It'd be really nice to have a debugger. Absolute requirements. Print k comma mv. So it seems to think that it should be 1. What the hell is -2? Oh god, something is very jacked. Okay, K. All right. Am I treating K as... No, these are real points, right? These are real points. I was worried I had done yet again the thing, but no. Okay, so I1 should be to the left, so assert K is greater than I1, and then here is that it? Almost there. Almost. Okay. So get rid of the prints. Okay. So I just want to know print K, comma, MV. And it should be 5. It should be 5, not 4. So we got to figure out which one of these is misfiring. Print restrictions. Okay, so yeah, and then this should be 4, 5 because it's a step of 2. So adjusted equals that. We'll call it adjusted 1. And then adjusted 2 equals that, and we have adjusted 2. And just 1, adjust 2. Let's figure out where the value is coming from. Obviously 7 is wrong. 7. Oh, interesting. It's starting out too low. Is K in absolute requirements? Absolute requirements. No, it is not. So where is the value for MV being populated? It's not being populated. All right, sweet. Okay. I wish that were the end of the problem, but I'm afraid that is not the case. We have to figure out if one number is between 2, what is the actual center point that we should be using, right? So we have, so let's say from point 1 we have 4, and then from point, I don't know, 50 we have 200. And so where is this going to, where's the max going to be? So for any point in between the two, so it'll be max 1 equals max 1 of position equals 4 plus I minus 1, right? And then max 2 of I equals 200 plus, yeah, 50 50 minus I, right? And this is just going to be position 1, and this is going to be position 2, and this is going to be amount to, let's call it limit 2 and limit 1, right? And we want to know where these are equal. So we're going to have limit 1 plus I minus P1 equals limit 2 plus P2 minus I. Let's see here. So 2I minus P1 equals limit 2 minus limit 1 plus P2, right? And plus P1. And then I equals this divided by 2. So limit 2 minus limit 1 plus P2 plus P1. And if that's outside of the range, well, if that's outside of the range, then what do you do? Well, we've already adjusted all of the ranges, so we don't need to look at things that are further out. But I think if this gives us an invalid value, then we just don't worry about it, right? So let's come up here. If it is an invalid value that doesn't matter, then we simply do not care. Okay, CI comma CM in restrictions, last CI, and we would need I think this is the wrong way to do this. Okay. Okay. Come here, indent properly, and then we're going to say, is this inside of a loop? No, it is not. So we're going to say for I comma j in range loop range length restrictions restrictions starting at 1, so that one is the one on the right is going to be higher, right, which is what we are calling limit 2. So position 1 limit 1 equals restrictions of I, and then position 2 limit 2 equals restrictions of j, and points to check dot add p1 1 minus 1 p1 plus 1 P2, P2 plus 1, and P2 minus 1. And this is what we need to find. We need to find this midpoint here. So midpoint equals limit 2 minus limit 1 plus P2 plus P1 divided by 2, integer division. Yeah. Trivial. 1, 2. So m minus 1, m plus 1, and m. Okay. Too high, huh? All right, use test case. So clearly, it thinks that it can arrive at a 3 when it can't. Let's figure out why that is. Probably pretty simple, right? So if mv equals 3, then print adj1, adj2, and the location is going to be position k. Right, and let's say k plus 1, because we're going to be comparing it against its values. So 7 is 3. Okay, but this should have limited it. Let's get rid of the plus 1, and let's look at the restrictions. Okay. So 9 is equal to 0. 8 is equal to 0? Really? That seems too extreme. So at 6, they're getting 3. So 3, 3, 6. So it totally thought that it could get it from the left and from the right. Now from the left, 5, 2, that is correct. But from the right, wait a minute. That's right as well. Where is this 8, 0 coming from? Is there a 9 in there? Yes, there is. 9, 0. Move it over 2. And it would indeed be 2. Okay. That means that there must be a bug here. IM. Yeah, so if ACM is less than IM, then we replace it with the smaller version, which is absolutely what we are supposed to be doing. So print ACM, CM, CI, II. IM. Yes, so this is there an 8? No, so this would have been 7. Which is not defined. It is defined. It is defined right here. This should propagate onto this, and it's not. So let's take a look. Okay. So ACM CM. So II, that is our position right here. The ACM is 3, and it absolutely should be 2. So that is weird. So the CICM, why is it backwards? That's fine, that's fine, that's fine. So the third number is the CI, the index of the place that it is coming from. So we're at 6, it was at 7, and then the CM is 2. CM is 2. Why the hell is CM 2? Well, I mean, that's the problem right there, right? ACM is less than IM. Are we not replacing IM? IM gets read just the next time. Well, yeah, then where is CM coming from? CICM. Yeah, you're right. CICM should always be stricter. Stricter or equal to. So we calculated off CI and CM, but we don't actually update them until we have detected that ACM is lower. II and I and ACM right here, and then we overwrite it. So this is supposed to be the lesser. It seems like we're getting the wrong value even earlier, though. Why are these in order? They're not in order. So yeah, it does sort of seem like II should come first, though, just for debugging purposes. Eight, 7, 6, 5, 4, 3, 2, 1. So print restrictions. This is our restrictions before we begin. Actually, let's print our restrictions right here, because I need to know if they have been updated and what the latest version that we're looking at is. Because this is the problem right here. ACM of 3 at 6. So we should be going off of the previous value. which it should be going off the previous value. So this is the actual mistake here. Yeah, I was looking at a red herring. So, and we're not overriding 8-0. So IM is less than ACM. It's as simple as that. CICM equals IIM. Whew. And honestly, the same thing should happen up here. CI comma CM equals II comma IM. Oh, come on. Are you kidding me? Why? Why is it running out of memory? Does it at least say what line it ran out of memory on? Of course it doesn't. I mean, it can't store a set of integers? Like, how little space does it have? Yeah, okay, it's not there that it's running out of memory. I'm actually kind of at a loss here. I do not know where it is running out of memory. Yeah, I mean, I should be able to store any intermediary results, right? I guess I recreate it here, but I mean, so what, you know? Interesting. This is positively fascinating. No, it can't be that. It has to be. There's nothing in my problem that is particularly memory intensive. Is there? Am I like... I mean, these are ranges. And we determined that that isn't where it's failing either, so. Restrictions. Does this matter? Like how little memory does it have? See if this works for the other ones. Can I run just this test case? I want to run just this one. Okay. We'll save this test case. All right. I want to know if this works. Okay, that does work. So I guess for I in range length restrictions, they give me like 15 kilobytes of RAM or something. Restrictions I of 0 minus equals 1. Then we can keep from remaking it. I think should still pass. Range. All right. 0 equals II. 1 equals ACM. Okay, come down here. 0 equals II. 1 equals ACM. That way we're not remaking objects, especially not multiple times. Okay, so now we're using it in place. We have these, but I mean, there's not that many. They're integers, for hell's sake. Sorted points to check. Yeah, that shouldn't matter. I mean, is it at least close? Do I like have to prune this or something? This doesn't make any sense. If it can load the problem, all right, return 0. It can't load the problem in memory. Oh my god. Oh my god. Oh, fuck my life. No. That's hilarious. That is actually kind of hilarious. Output limit exceeded. All right. Well, I don't really think that I did very well on that problem, but you know what? I got it, so it's all good. All right, see ya.